Hi everyone, welcome to another series of Dogen videos. On the previous series, coding videos I mean, because of course we have the demo, which is completely separate from this set of videos. These are more just a set of videos to describe how Dogen coding is performed, partly just to keep me motivated, partially to also explain to people how you can use Dogen and how the internals work and that kind of thing. So the previous set of videos, very long videos, were to do with implementing the relational model. The main reason why we did that was because we were trying to implement a new meta type, which was the registrar, this chap here, and that meta type was not working so well. We couldn't get it to come through the generation. We didn't quite know why. The relational model helped us pinpoint the problem, and we fixed that problem and then solved it and moved on. Now our objective is to take a set of meta types that we have. These are not proper meta types, they're kind of meta types that we have living on the generation models due to our previous misunderstanding of how the meta type should work, and we are trying to move them slowly without breaking anything, one by one, over to the assets meta model. So the set of videos that we're starting today are going to cover the work needed to get the Visual Studio related meta types over to the assets model. So yesterday I started doing some analysis work on it and reached the conclusion that we've got sort of two separate use cases for this. The first use case is what we currently have, which is just at the component level. And just to recap, I mean, this will be a bit easier to explain once my thesis is published, but so the idea that we have in MASD is that we have products, and products are made up of components. Those components could be EXEs, they could be SOs, dynamic libraries, but they could be other types of components. So for example, you could have an infrastructure as code, sort of Terraform component, or you could possibly have SQL as a component. So we don't really make any assumptions as to what a component is. A component is just a well understood and well bounded part of a product. And in fact, these are two types of boundaries: the product boundary and the component boundary. And it's up to the user really to give meaning to that. However, what is clear is a component is normally associated with something that makes it a build file of some kind. And that is the sort of meta types we're kind of coming to analyze at present. Now, as it turns out, Visual Studio has this property of being simultaneously possibly a product level meta item, meta element, as well as a component level meta element. And the reason why is because in Visual Studio you have solutions and you have projects. Now normally a solution is associated with a product and a project is associated with a component. However, there is a special case, and that's what's happening in Dogen at present, which is sometimes you create a component that has its own solution. Now how useful that is probably up to debate. Excuse me, but that's where we are at present. So if I just quickly go over to our project. So I'll just show you two examples of what I'm talking about. So if I just quickly go to projects and open up the C++ model. So this is the C++ reference model, and this is the core model of that reference model. And as you can see here, we have both a solution and a project. So that if you would like to just build this chap, you can. In the future, we don't do this yet, but in the future, of course, we should really have a solution that takes all the projects from every single component, but we don't do that yet. And the reason why is because we don't model products yet. We will, but we don't just yet. So at any rate, so the idea then is that we need to somehow explain this notion of a Visual Studio component, either a solution or a project for a given component. Which is what we did. So this is a bit of a cleanup of the existing entities that we had previously scattered in the generation model. So in the past we distinguished between projects and solutions, and as you can see, projects and solutions are almost identical. Project good, project name, tools version is not being used at present, nor is version, and project solution, good. And then of course we have this configuration, which is a way to read the metadata. But now they're using proper metatypes, we don't really need to read metadata, we can just make this part of the metatype itself. So the idea of going forwards would be that in a model such as this chap here, you would create a Visual Studio component, you would populate it with the properties, which we will do probably today, and then that will get instantiated into one of these chaps in memory, and the code generator then will use this to generate either products or solutions. There's a slight wrinkle at present in that in order to create a Visual Studio project, at present we require access to all the files that are going to be part of that project. Now C++ doesn't implement this properly. If I show you our C++ model, you shall see that Visual Studio Project doesn't have any items. This is where the files should have been. There's none there. So clearly some more testing is required here, because I think this probably won't work. Having said that, we are using projects in Angular for C#. So if I go over to any of these chaps here, now this solution you see here was manually generated, so it's not actually done by Dogen. If I take, say, the C# model, and I look at its project, you can see here that there's a whole load of items which are in effect the files in this project. Now the reason why that works, and you can see of course there's this duplication here in terms of the Visual Studio components. That's one of the problems with the current setup. But what I was going to say is, if I go to formatables model, as they're known at present, we have this notion of project items, and the project items are populated by the project items expander. So this is just a clear modeling error, really. Well, there's several modeling errors. The first one is we came up with meta entities at the generation level. In practice, there shouldn't really be any meta entities at the generation level. And the reason why, of course, as you can see, is because different engines, or different engine is the wrong word, but different backends will require similar meta types, and then you end up duplicating everything. So that's the first modeling error. The second modeling error is, of course, we should really keep the properties together. It makes no sense for the model to have access to the project items when the project items is something totally specific to this meta type. So that's not very good. However, we can't solve the problem straight away, because files are really a generation concept. In other words, just to give you a bit of background, the way Dogen works is we do projections from spaces. So inside of assets, you're inside of asset space. In asset space, for each entity you've got in a meta model, asset space should have, for each entity you've got in a model, asset space provides you with one meta element representing an entity. So for instance, if I take, I don't know, any object here, say if I take this enumeration here, there is a corresponding meta element called enumeration that represents it. And so all of these are associated with that one meta element. So in effect, there is a many-to-one representation at the asset space, mapping from the instance model to the asset space. When you enter the asset space and you project the asset space to the generation space, what happens then is that there's a projection of one-to-many, and that then you start entering the facet space. So the idea then being that one single meta element could give rise to multiple files, because in reality a facet is normally associated with a file. Well, in fact, I'm simplifying it slightly, because a facet is made up of formatters, and the formatters are sort of the components of that facet. So the idea being that you have a header file, for instance, and that's a formatter, and you can have sorry, I think I'm being called. Just 1 second. I'm just going to pause it for a second. Nothing major, it seems. So as I was trying to explain, this will probably be easier with the diagram. In fact, let's just do a quick test here. I wonder if I could just draw something. What's the best tool for drawing? Inkscape, perhaps? or is there some kind of paint like tool? Let's just try GIMP. I thought GIMP was more of a photo manipulation thing, but let's see if we could just create a diagram for this. Now, I haven't done this before, but in fact, it might even be the best tool for the job. Let's just create a blank diagram here. So what I was trying to explain in a sort of a complicated way is if we take an object, so let's call this entity 1, and I always like to snap to grid because it gets very messy very quickly. So let's imagine that we have a number of entities in a regular user model. I'll call this entity n, you get the point, and then we just type here, we just call this user model. Right, so you have a user model, right? And then the idea then is that these entities in the user model are instances of a meta entity, whatever that meta entity may be. Now, of course, please ignore the UML elements that I'm using for this. These are just randomly picked purely for demonstrative purposes. It's not actually no semantic UML meaning here. Right, so now let's call this meta entity 1 or A, just to distinguish between the others. So this is what happens all the time in regular models, right? So and yeah, if I was to use some technical terms, this is what normal people call M0, and this is what people call M1. So, however, in Dogen, not only this is a meta model, but this is the assets meta model, right? And then what happens then is we move to generation space, and then in generation space the funneling occurs again. And the idea being that an entity is projected in this space to a facet, and in the facet there's a formatter. So we're running out of, well, let's use capital letters for this. So inside of a facet there's a formatter, and that formatter it can then be distinct and so forth, right? So what we're trying to do here is we're trying to say, and then what I'll do is, just to make sure that this becomes clear, is let's use real world examples, because of course these A's and the B's, and it's all very mathematical, but you start to get lost slightly into terms of the meaning. So now I don't want to call this a meta model, because clearly this is not a meta model. We really stop our modeling at meta models. So this is just the meta model, but a distinct meta model. It is a distinct meta model, and that meta model is represented by the facet space, which is inside of generation. The idea being that, and so if we get into more detail about what we mean, is what we're trying to then say is something like this. Let me just fix this. My OCD is not able to cope with all this unaligned things. So, for example, we could say that object car is modeled in terms of facets as the class header. This will be one facet in types. So that there's one facet. So one formatter inside of a facet. So the facet will be types. The formatter is class header, and then the facet could be types again, and the formatter could be the class implementation. And of course we have other facets, so the facet could be serialization, and the formatter could be a class header. And as you can imagine, this list goes on and on and on. So this multi-dimensional space that you're seeing here inside of the facet and facet space, I guess would probably be a very better description. this multi-dimensional space you see inside of the facet space is providing all these different projections of the same meta elements, just a simple class. And the way you configure, or the way you control these projections, is via variability. So you could say, well, I'm interested in, I don't know, serialization only. And well, obviously you always need types, but you need the type definition, you need serialization, for example. And then using configuration, you can say, well, okay, I will define a profile for a given model type that only enables what's required. So, and we do this all the time. So for example, if I take the assets model again, if I choose to be honest, the main use you're going to see here in these models is of configuration is to enable handcrafted types facets, as you can see here. But of course, if you go to the profile, you see all sorts of things here. For example, this chap here only enables types. This chap here only enables I/O, printing. This only enables hashable, and so on. So you can use any of these stereotypes to enable the configuration you would like for a meta element. So this is kind of the projections that Dogen is doing, and then of course, just for completeness, if I then move over to the extraction space, then what you see then is again, this is a meta model. I mean, the fact that these things are meta model is not a hero there. I don't want you to get too hung up on that. That's not the important point. Really, meta model, as modeling people know it, is this chap. Everything up to here is just regular user code. And then what happens is, at this level, you enter the artifacts. And here I'm just going to call this guy artifact A0. I don't know why I deleted that. And so as you can see, then we're going to end up with just make sure we did put recording on again. Looks like it. And you're going to end up with a whole load of these chaps. And now the mapping is just one-to-one. And of course we seem to have chosen the wrong type of arrows for some reason. No, this is right. So I don't know why we're getting this weird arrows pointing the wrong way there, but seems like a die artifact. Right, so on the extraction model, which we call the meta model, I'm just going to avoid the word meta model altogether because I think this is just going to confuse everybody. So let's just imagine these things are just models. They are in fact meta models, but just to simplify things slightly, we'll just call them meta models. We'll just call them nothing. And of course you can imagine that there are boundaries around here. So if we just take a simple line, we could just say something like this. I'm sure we can change dashing somewhere. Oh yeah, so just take one of these. Right, so yes, dia is quite a useful tool, really. Shame we haven't got any upgrades of dia, any updates with dia for GTK 3, really. But hopefully at some point we'll have it. Right, so as you can see here, this is kind of the core architecture of Dogen, really. All these projections that you see across spaces is really where the meat and bones of Dogen. Now, now hopefully you can see some of the problems that we're facing at the moment with the ability to know the list of files for a given model, because we're inside of assets in this M1 space. I'm not entirely sure where. Sorry, let me just fix this because it's going to annoy me. So user model M0. Right. So as I was saying, now you can hopefully understand the problem that we're facing with solutions in any kind of build file. We need to sort of understand the list of files that's going to be generated, and the extraction really is mainly concerned with the actual shape of what's going to get written to the file system. So we don't necessarily need to go all the way to extraction. Generation probably already knows everything that needs to be known in order to generate what's in extraction. So it's almost like we need something like a pointing back arrow from here to here. In other words, how can something that lives in the assets model know about the things that are going to be created as part of the expansion or the projection over to the generation model? Now, this is not a big problem. I mean, Dogen is not it's just an academic exercise. We don't, and this is one of the things I want to defend quite strongly in my thesis. I think you must understand the difference between a model and a theory. A model is limited. And if you read Derman's work on this, it's actually quite good. I couldn't recommend highly enough. Let me just show you the book, because I think everyone should read this book that's interested in this sort of stuff. This chap here, I could not recommend highly enough this book. If you really want to understand the differences between models and theories and understand exactly what's the point of having a model, you really should read Models Behaving Badly. It's a really, really good book. Mendel Derman is a really kind of nice and clear writer. All of his books are highly recommended, and if you are interested in financial stuff, I also recommend his financial books. Of course, this book is all to do with models in finance, but really it doesn't take a lot to be able to understand that he's talking about models in general, not just models in financial markets. So I honestly, for me, I think that to start to create arbitrary divisions in the way things work, in other words, to start to focus on the strictness of models, is a bit to miss the point. Models are supposed to be useful for a purpose, and if it's not doing what you want it to do, you should just change the model. You shouldn't be too hung up on some architecture. So for instance, we are defining this architecture. It's nice that the architecture is a one-way architecture, etc. and so on, but the point of it is to generate the right files. So if we need to create linkages between layers, then we should do that, as long as there's a rationale for it, and as long as we don't start making things too messy. So the way we propose these linkages is to say, well, we know for sure that there's going to be a need to know of these things that we need to populate. Now, remember, we know that these things are files, but it's important for us not to get confused. What we are modeling are not files. We are modeling entries in a Microsoft Visual Studio project. And that means we need to use the language of the Microsoft Visual Studio people. So in this particular case, Visual Studio projects are MS Build items, MS Build instances. In other words, MS Build defines a schema, and it defines what should be on it. And these MS Build schemas have a very, very precise language. The things that we are trying to model are items inside of an item group, which, if you were to look at the Visual Studio XSD, you would see that it contains item groups. In fact, to be honest, you probably can even see that from our, if I go back to here, you can see here that there's an item group, and the XSD defines the entries in the item group as items. They have a name, and they have includes and excludes. And so what we are modeling at the meta level is that entity, instances of that entity. It happens that those items get populated with files, but that's just a quirk of the instantiation. The modeler is not really too interested about the instances. He's more interested about the properties of at the meta level. So therefore, the correct way to model this is to say that there are items that belong in an item group, and for there to be a transform inside of the generation space where we have access to files, because of course, as I explained, files arrive as part of the projection of assets into the generation space, sort of at this point we know that there is a file name, although we're not actually using it directly, it's just a property of the meta entity, and at this point we associate the artifact with the file name. So anywhere around here we know what the complete list of files is in a given instantiation or projection of an entity. So we need a transform in generation space around here somewhere that collects those entries and then updates the meta element, which is this chap here, with those entries. So in other words, this follows the pipeline logic quite well. In the first step we adapt a meta entity from a user model by populating what's available directly in it, so the goods, the solution good, the name, and so forth. But we don't touch item groups, we leave item groups for later. And then at the generation level we create another transform around here somewhere that finds entities of that type and has access to the model with the right expansion, with the right projection, I should say, and extracts the file names and pushes those over to the meta entity. And so that will be the ideal scenario. Now, of course, and that's all very nice, and that's all in accordance to the Dogen architecture. Of course, the world is not that simple, because remember, we are in this massive, long refactoring exercise trying to clean up the mess that we made here in the generation space. And due to that, we won't be able to use the properties that we are looking for just yet. The reason why is because we haven't yet moved the file name generation from the generation projects to the top level generation. So at present we have a locator in the C# generation model, and we have a locator in the C# C++ generation model, as you can see here. We did all the hard work of abstracting them to a common model generation, but we got stuck when we're trying to actually put this in practice because of the fabric entities. So in effect we're kind of more or less stuck in a loop at the moment, whereby we can't move the fabric entities into the assets meta model, because there's aspects of the path generation that are not haven't been done. But at the same time we can't move the stuff that's inside of the formatables namespace, which is what I just mentioned, the locator and so on, over to generation, because they also rely on the assets being in the assets meta model. So the way to break the deadlock is to try to separate this into two different exercises. We're going to first move the assets, and then once we finish moving the asset by whatever means, hook or crook, we're just going to need to move these assets and get rid of this fabric namespace that shouldn't really exist. Once that's done, we're then going to start working on moving what's in the formatables namespace to generation. That means we're going to have to do a number of hacks just to get this working. The first hack we're going to do is we're going to take the existing project items expander, and we're going to modify it to update the Visual Studio components, and that will give us a quick way to create item groups without touching anything else. As we are not using this infrastructure in C++ at present, we shall just delete everything that was associated with it, so project items and so on. The idea at the moment is not to make things better, just to make things the same. We'll work on making things better once everything has been refactored. So hopefully that didn't confuse you too much. It all makes sense if you bang your head against the wall, this kind of thing, for years. Sadly, it's not so easy to explain, but it should give you at least some context as to what we're trying to do here. Now I'm going to try to keep these videos small-ish. We've been recording for about half an hour, so that should be fine. We'll keep going for a bit more. So as part of this video, our objective is to give you the context of what it is that we're trying to do, and then start the first bit of work, which is actually supposedly a simple bit of work. We just need to populate the properties for the assets meta entity, which are the project GUID, project solution GUID, the project name, and read those in the adapter. So the way this works, we should really probably say that we are working on a video. I'll separate the time for this afterwards, but interestingly enough, let's just clock this now and create a task here. create videos for, so create new playlist for assets work. So create a series of videos describing the refactoring of Fabric into assets. Now, if we have time that's actually spent just because of the videos, then we should probably not quite sure what I've done here, but not quite what I meant to do. Actually, I think, okay, right, fine. Clearly not sure what I'm doing at present. This is one of the disadvantages of videos, that your productivity goes down a fair bit as you faffing around keys whilst trying to think and talk. Right, so this was only time that we spent specifically doing video stuff, so I'll clock that as part of the cost of doing a video. And now that we're actually doing real work, I can clock this into the real work. But as I was saying, the work for this video will just be to try to populate these Visual Studio components. And what we'll do is, we've already started this work, as you can see here. I think at present we just read the elements, and there's nothing else on it. So what I'll do is just to show you what we're doing. So I'm just going to hop up here to the namespace, so to the area workspace where we are doing C++ ref import work, and I'm going to just output some tracing information here. So we don't need to use a database for this. We can trace to file, which is already enabled, just to log. So if I just do something like generate C++ ref import simply model layer, and then let's see if we have an area here for the shell. We have the Dogen shell. Let's open up a new one. Area 9 perhaps, because 8 is normally a database. So in here, what we'll do is we'll open up a shell, and we rename this shell to be C++ ref import. And we don't really need Emacs for this. We can just quickly go up to build, output. Let's just get rid of this clan gate, because we moved from clan gate to clan 9 a long time ago. We didn't use that. The Dogen byproducts, if I look for C++ model, look at the log file. Actually, to be honest, let's look at the tracing. So what we're looking for is we're on the conversion, sorry. What I meant to do is to look for the generation. So if, this is now dumping the complete sort of tracing chain, tracing of all the chains in this generation. So as we move from injection to assets, which is here, engine transforms injection model set to assets model set chain. So around here, one slight problem that I always find with these dumps is that it's actually quite difficult to understand what model the transform is working on. So for example, here you can see we are transforming a whole lot of injection models over to the assets representation, but I can't tell which one is which. So there's no way figure this out other than JQ dot the output, which is not fast, because these are, well, this is actually a small one, 246k, but some of these models are quite large. Sorry, 625k. And JQ, although it's fast, is not quite as fast as you'd like. So this is really not ideal, really. We should somehow populate the name of the model as part of the tracing information. so that we, in fact, let's just, this is actually quite a good requirement. This is exactly what Dogen development is all about. You start doing something and then you figure out, this is actually really silly. Why am I wasting time on this? And then you just fix it. And a new story comes up and you implement that story. It's all designed to make life easier. Not sure why JQ is taking so long. It's not that big a model. Sadly, because it's not using async when we run this Emacs. We can't do anything with Emacs, so I can either kill this or wait. Give it another couple of seconds. Okay, it's taking too long. In fact, I wonder if I can kill it. I might have to actually kill JQ. I'm not sure why JQ is so upset, but let's have a quick look at what top says, actually. No, not alerting JQ. Oh, okay, so the problem is JQ is probably very, very quick. It's, the problem is Emacs, which is even more worrying. I'm not entirely sure why Emacs is so unhappy. To be fair, I don't tend to have this problem very often. Perhaps it's because OBS is also using a fair amount of CPU and Emacs is struggling. This tends to happen if you use very long lines and files, but the files coming from JQ actually are quite small. The lines are quite small, so it's normally not a problem. Okay. Might have to give a signal to Emacs then. No ideal to start signaling, so let's just give it a few seconds and try to find something else to do while that's going on, because I don't like giving sig USR to Emacs because it never quite comes back the same way. It always starts behaving a little bit funny after you start sending some signals to it. So I prefer avoiding that. Okay, cool. So as I was saying, the objective now is going to be to try to yes, exactly. So what we want to do is, while we wait for Emacs to do this silly thing, is we want to be able to figure out what transform is causing, well, what's the transform that is being done to convert from an injection representation to an assets representation, because as part of that transform, the adapter is being called and it's generating this Visual Studio meta element. So if you can look at the output of that, then you can see what you know, if we're being successful in adapting or not. So that's why I was looking at that log file. What we'll do is, meanwhile, we'll just save this chap here. It's a completely wrong directory. I'll save that in a minute. JQ is really... oh, here we go. So, not entirely sure why Emacs is so upset. Just for a laugh, what we'll do is we'll just do a JQ and c.json instead. See, JQ is extremely quick. Now what happens if I try to... okay. Interestingly enough, now it's a 1.2 JSON file, but even that is actually quite quick. It seems like the problem is if you JQ onto a region rather than JQ over to a file, which is a bit silly, really. At any rate, what we all wanted to know is what is the name of this model. All of that's for that. The name of this model is, oh, as luck would have it, is exactly the model we're looking for, the C++ model. Okay, sheer luck. Okay, so if I was to, in this model, if I was to have a quick look at what's in it, we should see, hopefully, Emacs is still behaving slightly strangely. I think one of the problems is the JSON mode. JSON mode seems to be a bit slow. I think I've enabled something on JSON mode that's causing this. Making it really, really slow. Perhaps it's something to do with the guidelines. I think the guides, you know, these lines you see here. I've seen that on a profile before, because it's really weirdly slow these days. Certainly computing something, not entirely sure what. But yeah, I think I'll have to enable profiling at some point and then try to understand why my Emacs suddenly is misbehaving a lot in regular JSON files. If this was just plain JSON, it wouldn't be a problem. It's either the expanding and contraction of nodes in JSON, or the guides to things I've added recently. To be honest, guides are just because they look nice. I think it's a bit of a expensive thing to have if it's costing me time just to look nice. Can't say that I've actually used it for actual practical purposes, shall we say. So we're stuck again. Oh, okay, while we wait for Emacs, let's just get our terminal up and running. Where are we? So we're looking at the C++ rough import integration. Build, output. Right, so whilst that Emacs is really not behaving, we could just go up to the byproducts directory, and in here we have all of our stuff. I'll just leave it side by side so we can see when Emacs is ready. We will avoid doing silly things with that. Where are we then? So if I go into tracing and if I look for the 01, I believe, c.json. So if I just go to c.json, right? So what we're trying to show here, Emacs not allowing us to. So this is a complete model. Of course, it's quite large, quite big, lots of JSON here. But you'll see here there's these collections, so structural elements, for instance. There'll be quite a few of these. So if I was to hop over to a model, in assets, what we're looking at is this chap here. And one of the things here at the very bottom is the build elements, right? And the build elements, if I just G to the bottom, there it is, the build elements. Let's do another Control G here in Max to see if we can help it along. Really not listening. So the build elements will contain, well, as you can imagine, a Visual Studio component, this chap here. And the Visual Studio component at present will have hopefully no project GUID, no solution GUID, and no project name, as you'd expect. The reason why it doesn't is, well, for two reasons. First, in our C++ model where we're testing this, there is nothing populated here. Secondly, the adapter, which I would show you in Emacs if Emacs would allow me to, is not, the adapter is not adapting those fields yet. So our task is, for this first video, other than the explanation of the context of what we're doing, is to try to see if we can get the adapter to adapt those fields and to try to get that model populated. And we can just double check that by seeing it coming out here. Now our JSON mode is really and truly screwed up Emacs. And sadly we can't do anything until we get control of Emacs again. So I might be forced to send a sig USR1 to migrate. Disappointment. One thing I do profoundly love Emacs, but one of the things that we really need to improve is this async story, because I don't mind things taking long, but the fact that I can't kill things is the biggest problem. If I could just simply within Emacs make it stop when it's doing something slow, my life would be much easier. So now we start sending these signals to Emacs. As you can see here, suddenly. But as you can see, the problem is clearly highlighted in guides. So let's just now you can see Emacs is now going to start misbehaving quite a lot. This is what I dislike. I find that whenever you give one of these signals, you end up always with a very non-functional Emacs. And then you end up having to do about 10 of these. So let's just debug on error. Okay, hopefully debug on error is disabled. Right, so what we need to do then is, I'm just going to do something very quickly, hopefully. I need to do this properly, but we'll open up the file again. I should really put this down as Emacs fixing time, so we started around maybe 10 minutes ago, perhaps 9:51, maybe about 9:40, try and solve this problem. No, it seems like Emacs even loading the file is too much. Okay, fine. Have to go back to the debugger. This a few times. Close the file. Okay, now global highlights. No, I think that's okay. No, what's the name of okay, so enabling it, so I want to disable it. So in order to do this, we need to figure out. Okay, let's just. I'm gonna have to switch topics slightly, because as you can see, this is a bit of a pain in the ass. So and to be honest, this is also part of Dogen development. I mean, this is also a very fair reflection of what happens with us. Every so often bad things happen and you have to deal with it. So in fact, we should really have an area. See, this is the problem once we start messing around with signals. We now see all the errors coming through. I'll have to restart Emacs at some point today. So what I wanted to do is to, oh actually I know what I wanted to do, which was not this, is to create another area for Emacs development. So I just swap up to, say, 10. Let's create another area for Emacs. There we are. And so if I just quickly grab here for indent. I know I was trying to keep these videos topical, but I think it's important for you to see what really happens. So whenever there's problems, one has to fix these things. Right, you see here, we're adding these indent guides to the prog mode. Now, that's alright, but the problem I think is that JSON mode is part of prog mode. We don't want indent guides to be enabled for JSON mode. So we will have to, I think we will have to enable it specifically for modes. So for instance, if I was to do a quick search for add hook, and this is another disadvantage of not knowing Lisp very well, and that's not what we want. So we're clocking all the time for 9:40 for this Emacs work. So yeah, because I'm not really that proficient with Lisp. Okay, so here we are. So it's buffer local, not global. So okay, that's fine. Okay, we like this question. Unfortunately, we're not part of this thing. We like this question, but the problem is this is quite slow. So see if anybody swipe. Well, do you know what? What we're going to do is, since we're going to have to restart Emacs anyway, sometimes you just have to go for the simple approach. And the simple approach basically says, I highlighted it, guys, is nice, but it's causing slowdown. JSON mode. So what we'll do is we'll just disable it, and on our next restart we will have this without indent guides, which I'll do for the next video, so we won't see any indent guides in the next video. And that kind of solves our problem for now. If we just go back to 9, what we need to do here is just be very careful that when we open up any JSON files, which you probably won't open it from Emacs, just to be on safe on the safe side, and we will just leave these guys here in this space, which is C++ ref impl shell. Okay, and that will allow us to then deal with all the problems. So all of this to say what? Once we finally figure out what we're doing, we should be able to see those entries populated in the JSON, and we will just use the command line to visualize the JSON rather than Emacs, and then I'll restart Emacs for the next video, so that we don't have a problem with indent guides. So that's the problem solved. So okay, so what are we trying to do then? So now we already said we don't need version and the tools version, because these things are not being used. Those are being used. So let's have a quick look at what Clang thinks is an error. No particular error here. Just reopen this file in case there's any weird issue with Clang. So we populate our elements as everybody else does, and then we can copy and paste from somewhere else something like this. So we then have to go to each attribute. Probably don't expect the name to be empty. Something like this, really. It's quite straightforward. So we are going to take the injection elements. We're going to find these attributes, and then for each attribute we're going to make sure they're not empty. Then all of these are not applicable to us, so and we will need a few of these, and we can then say, well, if you find this chap, please populate the project good with V. Something as simple as that. And if you find this chap, please populate the project solution grid with V. And V being obviously the attribute value. And if you find this chap, and as you can see, I mean, you probably think, oh my god, problems with Emacs, this and that. To be honest, I'm a strong believer that environments, well, everything in programming has to be incremental. You try something, maybe it makes your life easier, maybe it doesn't. It's all about experimenting, really. And then, if things don't work, you just... the important thing is to get things going. So for instance, in this particular case, we're just going to remove indent guides altogether, and then at some point we're going to have a little bit of time, and we can perhaps enable it for specific modes. In fact, to be honest, the obvious thing, sorry, what I meant to do there is, obvious thing we can do here is not even to disable it for everything, but to enable it only to C++. So we just need to know what the C++ mode hook Emacs is. And there's about 1 million of them. Hopefully somebody is gonna tell us what we should hook into. So there's a specific C++ mod hook. there is a CC. There's a scene insertion hook. Well, clearly you see we're already taking too long here, so what we're gonna do is okay, cool. So let's try that. So let's add a hook to the C common hook, and that would be for all the C-like languages, so C# and so on. Right, so this limits a little bit the scope of the event guides, and it doesn't affect JSON anymore. So hopefully that will help. Okay, so what we're going to do now is just very quickly, let's just clock time properly. So we spent fixes with Emacs setup. Time spent fixing Emacs issues. So this will give us, we normally tend to add these things in a sprint whenever we start to see that we're taking too long in Emacs. So I think we set something like 9:40 to about 9:55 maybe. About 15 minutes that we spent here trying to fix Emacs setup. And here we said 9:36 to about 9:40, which means we should probably just do 9:41. And then from 55, I know you probably think, oh my god, we are spending so much time for all these minutes of actual clocking, but it's important to do this, and the reason why is because we need to know if we are spending too much time faffing around with Emacs, we need to know, because it's costing us money really, and we need to make sure we don't spend a lot of time playing when we should be working. So it's important to keep the clock fairly accurate on the work that you're really doing, as opposed to messing around with things that you're not supposed to be messing around. Okay, so what we'll do is we will, well, first thing first, let's just run the tests. If the test failed, then we know for sure we got a problem. Okay, the tests have passed, so that's good news. Now we hop over to the C++ ref import model and regenerate this version of Dogen. And if you go to our shell, now we just have to make sure that we don't make the same mistake as we did before. Shell was number 9. So if we just go into build stage, build output clang, release stage, or in fact you don't need stage, Dogen byproduct, CLI that generates CPP model, and then in tracing, right, so in tracing we had engine transforms and 0, 0. Hopefully we'll see. Of course our oh, actually it does look like we're in the right place. Yeah, so presumably it is here. We need to, sorry, my bad, we need to go into the 0, 0, 1, that's why. Of course that file that we generated is gone now, because Dogen deletes everything on that directory. But hopefully a reasonable guess is that it's the same chap here. So if I just JQ this chap here, and then now let's just be a bit optimistic and just tell the last 50 lines maybe. Okay, JQ is not happy with that file. Okay, that's peculiar. One thing we shouldn't have done. It looks like a perfectly reasonable JSON file to me. And as you can imagine, of course, this is not a good idea. Not having a good Emacs day today. As you can imagine, this is going to greatly slow down Emacs. Okay. So why is JQ not liking this? I'm not entirely sure. Really not having a good. I'm sure we just. But of course. Of course, now we are in the directory. It doesn't exist anymore because it got deleted. So yes, I'm pretty sure that all we did a second ago was to JQ that file, and that just worked. Can't see it anymore, but JQ001. We are really having a lot of problems today. Oh, I had this problem before. Clearly we must be generating some invalid JSON. However, I'm not entirely sure where. So if I just less... Of course, because you can imagine it's not going to be trivial to figure out where the problem is coming from. Because it's one long line, so as you can imagine. What we tend to do in sort of cases, I mean, this is really now you are far from the typical traditional development issues, but nevertheless, one thing we can do for these kind of scenarios is to use something like JSON online, JSON formatter or something like that. There's always some tool somewhere, and if we open up that file. So we were in. Let's just go up to here. So in here, output, clang, release. Righty. So if we go to byproducts and look for the C++ model. There's the boost model, C++ model, there we are, tracing. And now I just have to be very careful to open up the right files. Injection model set to access, that's the one. And then if we look for this chap, drop a file, okay, let's drop a file then. Hopefully this will be slightly more helpful in terms of telling us what the errors are. It's even slower. Okay, this is taking its time. Let's look for another site. What happens if I drag it? Nope. Upload data. Upload file. Now I need to find the whole path. So, as you can clearly see, this is not being what you'd call the ideal setup. Okay, what is your problem now? Oh, okay, seems like it didn't. Okay, cool, there we are. So let this just to undergo. Okay, here we are. Okay, sadly, we're not finding any errors. That's a bit disappointing. Well, this is what you'd expect, but clearly just JQ violently disagrees with us. I honestly never have had this problem before, where JQ is unable to parse a file and there is no good reason for it. I'm very puzzled as to why this is happening. Okay, but we're just gonna have to chalk this down as something else to look at. What we were interested in was we regenerated the file, so let's just try to get back to the problem at hand. I mean, we are really getting lost with issues here. So we were trying to look for items in a collection. Now we just have to make sure we actually open up the right file. So we have an assets meta model, that's good. Let's just try to get rid of some of the nonsense we have here. So this is just the name, meta name, references, leaves. Right, so root module we don't need. At some point here, oh, here we go. So now we start with structural elements, decoration elements, variability elements, mapping elements. It's about a few of these, of course, rotation elements, build elements. Right, here we go. Finally, where we should be. And hopefully we should now see, well, actually we're not going to see anything because, of course, we haven't populated these yet. So as you can see, they're blank. I mean, this is all very complicated for no good reason, really. We still don't know why JQ is misbehaving. I'm very disappointed with JQ today. I must be doing something really, really silly. Perhaps what we should try to do is to, I mean, we are really going a little bit out of range here, but perhaps not with Emacs, I guess. vi crap.txt, insert, paste. No, I'm still thinking. Unfortunately, I'm not the most, the best VI user in the world. There we go. So if I just had crap.txt, okay, that looks good. So what happens if I JQ crap? See, JQ is really, honestly, behaving very strangely today. This should, I mean, if it's perfectly regular JSON, it should have just worked. So it's almost as if we're not, it's actually not interpreting this as a file or something. Let's just to double check that we're not doing something very, very silly. JQ file. I'm sure this is how I always use JQ, but what's that dot you need to put in? Sorry guys. So my bad, sorry. Suddenly just, I don't know why, I just completely forgot how to use JQ. Oh, my bad, okay. So really, all this time that we wasted was just... And see, this is what I was trying to say a second ago about the videos. The problem with the videos is that somehow you lose concentration slightly. If you do these silly mistakes, that then cost you a lot of money, a lot of time. It would have been something that would not happen if I was actually coding normally. Anyway, at any rate, let's just then do the thing we're supposed to be doing, which is to go back to this model here. And all we need to do now is to say, well, we have a new meta element, we're reading these three new properties. Can you please supply them? And so we'll supply them one at a time. C++ model and attributes. Of course, the idea here is you're describing a new meta element. One very annoying thing about Dia is that you can't actually copy and paste from notes. So whilst what I want is just over there in the notes, I have to open it in Emacs. Not even here. these projects. So I have to go all the way to Emacs, obtain this diagram, and then look for right, so now let's just be slightly careful here. So this is the project grid. So I have to go to Emacs, obtain the project grid, paste it here. So as you can see here, now we have a project grid. Then we go to the next field, which is the solution grid. And we go to the next field in the model. So as you can see, what we are trying to do is actually quite trivial. This is why I decided to do this as the first video, because I thought it was going to be a 5-second job. But Emacs and my silliness with JQ conspired to make this a very long task. And the project name, to be fair, I think we probably shouldn't have a project name. Well, actually, the project name is probably going to be the component name, isn't it, really? So that is the project name. Really. C++ ref. And I think that's just a modeling error. Okay, cool. That's good. That's good. That means we have got even less elements here. So we'll leave that one blank. And what we'll do is we'll just go back to 6, where we are. Let's just regenerate this chap. Go back to here. Now, of course, we need to do the whole A equals pwd cd $ls, and if I then jq dot, let's not forget dot this time, and then we look at the bottom. Interestingly enough, it still comes up blank. Maybe save. If we look at yeah, we definitely saved. You can definitely see the properties here, so that looks good. Are we running with latest Dogen? Make sure we compile. Nope, no work to do, so that looks good. So when we generate the model... okay, error. Attribute is not supported. Project solution good. Okay, cool. So let me just show you what I was seeing, which is this. Okay, so this is good. This is what we'd expect. This is reading these new properties. So let's go back to the adapter. Project selection grid, attribute name. Status, we'll just remove the project one because we know for sure we're not going to need that. Let's just do a bookmark here in case we need to jump back up again. And another bookmark here. So, well, that's interesting, isn't it? I would have thought project solution grid. Okay, like typo error. To be fair, we don't need to go to the terminal because just simply take you from here. Alright, there we go. And as you can see now, life looks much better. We have good, and we have the solution good, and project name is blank. Okay, cool. So this is what we're trying to do all this time. The new meta element is here, is being instantiated. The name is now the name of the element. The GUID for the project and the GUID for the solution are coming through. We concluded that we don't need the project name because that's the actual element name. We don't have any item groups. As you can see, they're blank. So all of that is looking perfect. So now we just need to do a mop-up. And the mop-up exercise is going to... But first, let's just start committing one bit at a time, really. First thing is we're happy enough with adapter. Although, of course, we should run all tests, but let's just do that in a second. So here I want to say something like assets, adapts, Visual Studio, components, properties. That's good. Let's just run all tests as I was saying, just make sure we didn't break anything. And it's looking good. Show you, it's looking good. Now, after all the faffing around, let's get rid of project name, which we know we don't need. And that's very simple, we just need to regenerate. For that we can just generate all models. It's done, and then here you can see it's gone. Now this is a much more like the typical flow of typical Dogen development. Quick and very iterative. Run tests, change, check, commit. Okay, there's a break. The break is expected. We forgot to convert dogen.assets.dia. And as you have seen the previous videos, you know that we have a JSON representation of every model. The JSON representation contains a few, how should we say, quirks. At present we need to manually generate the JSON representation. In the future we will just generate this on the fly. Dogen does the conversion for us, but we have to actually tell Dogen to do it. Right, so away you go. Remove project name from Visual Studio component. We shall use the element name instead. Okay, very good. That's that sorted out. In the test pass. So we sorted this problem, and now of course we must make sure that we don't forget to do exactly the same in here, which is convert and indent, so that the model for JSON and C++ for dia are kept in line, and then we can say something like add properties to Visual Studio component in CPP model. Okay, that's all good. Now our model is making use, as we've seen a second ago, of these properties, and these properties are coming through, and that's all looking very good. And our assets model is vaguely looking like we wanted it to do. So I think we've achieved the objective of this video, which was taking a lot longer than expected, but we did, which is we are now, okay, I can see here that we are completely clocking on the wrong story. What we really mean to do is this, which probably means that we made a mistake here. No, we didn't, that's correct. Cool. Let's have a look at Git to make sure. Clocked everything in the right place. So some backlog grooming. This was some analysis we did early in the morning. This is the video work. This is the setup for Emacs. That's the actual work. That's not ideal. Oh, I think we just need to stage perhaps. That looks bad. Okay, cool. We've achieved what we wanted for this video, I guess. So, okay, let's just summarize, because there's a lot of things happened here. Let's just summarize what happened this morning. What we're trying to do is something very, very simple. We added a new meta type that was already there, and before the video started, I mean, which is the Visual Studio component. We explained to you the logic of how this meta type is modeled and why is it trying to replace the existing meta types that we've got scattered across generation, and why they don't make any sense. We explained to you the projections across the different spaces that exist in Dogen, which, to be fair, are a bit not the best explanation. I think you have to wait for the thesis to understand exactly what it is that we're saying here. And then we tried to update the properties of the meta type that were missing. We also found a modeling error there, so we fixed the modeling error. And now we know that this meta type is being correctly populated with the properties that we're using, and we have a test model. It's this chap here that is making sure that everything is coming through within the pipeline. So that's all for this video. For the next video, I'm just going to restart Emacs and get us in a good state. And then in the next video, we will discuss how we use these new meta elements to format, to generate a file. So we're going to try to generate solutions, and we're going to try to generate projects. And once that's happening, we will see that there will be problems because we need to do the hackery to do with C#. So that will be in the next video. Thanks for watching.